Hey everybody, welcome to Bill Sky, the Fortran guy. And oh, I'm excited about this video because we're going to get into some of the real benefits of Fortran. And it's really math. Fortran is all about high efficiency math. It's second only to assembly language if you write the assembly language code well. So it's used by scientists, it's used by mathematicians all over the world when they need really fast code. Mathematical code, they turn to Fortran. You'll find it at Lawrence Livermore National Laboratory, Sandia National Laboratory, NASA. You'll find it at all of these places. It's really useful. Let's just jump right into Fortran math. All right, so I actually would kind of like to do this in both GFortran as well as Intel FORTRAN, but let's start off with GFortran, and then I'll show you the simple change that you have to make to get the Intel FORTRAN to work. So what I'm going to do is I am going to create a new project, and let's not do the Intel. Let's go ahead and just do the Fortran or the GFortran. So I'm going to extract a project here, and then I'm just going to rename it. All right. And let's go ahead and edit our code. All right, here we go. Oh, it looks like I might have done this. I might have done the Intel FORTRAN. Now they're interchangeable, so that's fine. But I really would like to stick with the GFortran first. So let's go ahead. There, that one fixed it. All right, so let's go ahead and edit this. Now I'm going to edit it with Genie. Again, I'm on Linux. You can do this on Windows, whatever you want. And let's go ahead and just test this. Let's make sure that it tests out okay. All right, great. So the program works. Now, to do math, you either need to just do it with nothing but literals, or you need to create some variables. Now, if you do it with nothing but literals, it's really boring. The program's useless. So if it's just literals. So let's go ahead and using this template, I'm going to create some variables. Let's create some integers. Now we're going to be doing integer mathematics as well as real. So, and let's create a large integer, because what we're going to do is I'm going to show you how the default integer size is not big enough if you're going to be doing big math. So I'm going to create an 8-byte integer there, and let's create some reals. Let's create some floating points. And you really shouldn't name these variables these simple names. It's ridiculous. And then let's create, but we're doing it just for testing here. So we're going to do some double precision work. Okay. And something else I'm going to do, because I would like my code to print out really nicely as I'm doing these tests, I'm going to create a 1-byte character called tab, and then I'm going to assign to that the char value of 9, which if you look at the ASCII table, decimal 9 is tab. So pretty neat. You're going to see that in just a moment. Okay. So we've got the hello world. That's fine. All right. So let's go ahead and assign some data to some of our variables. These are just allocating memory. These right here are just allocating memory. They're not really putting any values into the variables. This one here is. It's actually moving the data into the variable, but that's a separate line than that. Now you can combine them, but I decided for this demonstration we're just going to leave them separate, the definition and then the assigning of data. So what I'm going to do is I'm going to say integer 1 is equal to 100, integer 2 is equal to 200. And now I'm all about making a few code changes and then rebuilding to make sure I haven't done something stupid. All right, everything's still looking good. All right. So now the next thing I would like to do is I would like to do simple addition. Now this is going to go pretty quick. Once we get addition done, multiplication, division, subtraction, those are all going to be almost exactly alike. So in Fortran, there is no such thing as plus equals like there is in C and C++. Java, I believe, also has those. So the equations move right to left. Now that doesn't mean it moves all the way to the right of the equation and starts processing. It just means that the right side of the assignment statement is done and then the data is moved into the variable. And that's the way it is in just about all languages. So what I'm going to do is I'm going to say integer 3 is equal to integer 1 plus integer 2. So what happens here is that the right side of the assignment symbol, which is the equal sign, the right side of the assignment symbol is done first. So that addition is done. So integer 1 and integer 2 are put into the CPU registers. They're added together. And then the result, which is normally RAX or REX, RAX or EAX on 32-bit, that is then moved into integer 3. So I'm going to go ahead and just build that. Okay, still looks good. Now let's go ahead and print out some data. We did the addition, but we don't see the values. So I'm just going to say print asterisk simple addition of two variables, integer 3. Okay. Now let's do another one. Actually, let's go ahead and save and run that. Let's save and build that. All right, great. So you can see 300. So you can see simple addition of two variables, 300. Now I would actually like to make this, I'm going to put a 1 here just so I can keep track of what I'm doing. And then what I want to do is I want to show you how you can also just add literals. So I could say integer 3 equals integer 1 plus, I don't know, 399. Forgot the plus sign. And then what I'm going to do is I'm going to copy my print. Now instead of putting the 1 there, I'm actually going to print tab and then print my data. So simple addition of a variable and literal. And you're going to see what that tab does. It's a neat little. Okay, so number 1, simple addition of two variables gives me 300, and here's a simple addition of a variable and a literal, and it gives me 499. And the integer 1 was equal to 100, and then you've got 399 plus 100 is 499, and you can see right there it works well. Now the simple math that we're going to be doing in this demonstration is not going to really be that highly, we're not worried about it being super high efficiency. But we're getting you started here. Okay, so that is addition. Let's go ahead and now say subtraction. So let's keep it simple. So I'm just going to make some changes here. Let's change this to 2. Subtraction minus subtraction. Very simple copy and paste. Again, the reason I'm putting this 1 and 2 is so I can keep track of what part of my code is running when I display it. And you can see there's number 1, so we know exactly what part of the code is. There's number 1, we did the simple addition. There's number 2, we did the subtraction of two variables, and then we did a subtraction of a literal. Now you could also do something like this. You could put the literal in front because the values on the right side of the assignment statement are not being affected. It's only the left side, the side to the left of the assignment statement or the assignment symbol. And you can see right here, there's our 299. So 399 minus 100 is 299. Simple, simple, simple. Again, math in Fortran is actually pretty simple. Okay, multiplication is not much different. Let's go ahead and copy this code for multiplication. Let's change this to multiplication and change our values for our output. And we're going to do some simple multiplication here. Okay, let's see how this works. And there you go. So you've got your simple multiplication of two variables, 100 times 200, which 100 is an integer 1, 200 is an integer 2, that's equal to 20,000. And then integer 1, which is 100 times 399, is equal to 39,900. Okay, very simple. And let's take a look at division. I'm going to go ahead and divide. Now, one thing to remember in division is that if you divide two values, if you want to see the fractional part of the result, you're going to have to do those in reals. But let's go ahead and do it here in integers so you can see the difference. So I'm going to go ahead and divide 200 by, is it 200? What is that? Yes, I'm going to divide 200 by 100. Let's change our output, simple division of two integer variables. Okay? And then we're going to want to probably change that to reals. So let's go ahead and now, and what were our real variables? Let's see. Our real variables, real 1, real 2, and real 1, real 2, and real 3. So let's say real 1 is equal to real 2, or no, real 3. Let's stick with some consistency here. Real 2 divided by real 1. And again, the division is with a simple slash. And you're going to see the difference here. Let's put some values in there. So real 2 equals 19.235. Just some number. Real 1 is equal to 10197.23. Okay. And let's change this division. And let's say division of two real variables. All right, simple code, quick code. Let's make it. Make sure we don't have any issues. We don't have any issues. Let's run it. All right, well, let's take a look at this output. So number 4, simple division of two integer variables. Now this might not have really been fair because we're taking integer 2 divided by integer 1, and integer 2 is 200, integer 1 is 100. So that's going to give us 2. So that gave us a valid value. Let's change that to 1. And so we're going to divide 100 by 200 just so I can show you that when you do it with integers, you're not going to see any result. And there you go right there. So the output is a 0 because 1 divided by 2 is 0.5. But because they are integers, it puts it back into an integer variable, which gives you 0 because it cuts off the fractional portion. However, here's a really nice example of two real variables. We put 192345 into real 2. We put 1987.23 into real 1. We divided real 2, which is the smaller number, by real 1, which is the larger number, and we got this really nice scientific notation. We got this really nice output. Now, take a look at my other video on Fortran on how to print numbers out, or how to use the print command or the write command, and you can see how to print those in different formats. So, because let's say you don't want scientific notation. Let's say you don't want the E minus 03. You want it to be, what would that be? It's 0.009679, and you only maybe want the first 4 digits of the fractional part of the result. That video shows you how to do that. So take a look at that. All right, so that's division. Now, let's take a look at exponentiation. Now, that's going to be our number 5. So we're going to do exponentiation. I'm going to put a comment here because I want to keep track of where I am. And actually, I would probably do that on all of these sections just so I can know what it is I'm doing to remind myself next time I look at the code. Okay, so I'm going to say integer 3 is equal to integer 2. Now, in a lot of languages, the language doesn't have a built-in exponent operator. It only allows you to use functions. Like I think it's POW in C and C++. There might be some other ones. But in Fortran, the double asterisk means exponentiation. And after I learned assembler in high school, I learned Fortran, and this was really cool, right? It's natural to me. So whenever I start a new language, the very first thing I do is I check to see if they have an exponentiation operator. And we're going to multiply 200 by 100. Let's go ahead and make sure I did that right. Okay, now let's go ahead and print it. So I'm going to say print, and we're going to make this number 5. And that number should be pretty big. Now, it built okay, but it showed me 0. It showed me a really, I mean, 100 to the power, or was this, no, 200 to the power of 100. That's absolutely huge. So what we might want to do there, because it overflowed. A 0 basically means that we overflowed. The result was 0. It doesn't make any sense. It doesn't give you an error. It just overflows to 0. And by overflow, it means that the bits that you've specified cannot contain the result of that number. Now, there is a way around that. I'm going to go ahead and open up the makefile. And there's the makefile for my project. And what I'm going to do is I'm going to put an argument. And I'm not sure if this is going to work because 200 to the power of 100 is awfully big, but not a bad idea to try this out. Let's put this argument in there. Whoops. And let me see. It is -f default integer 8. That means that I want the result to be an 8-byte integer. Let's go ahead and save that. Let's build it. And let's see if we get a difference. We still don't get a difference. Now, why don't we get a difference there? Well, the reason we don't get a difference there is because our code... actually, I'm not really sure why we don't get a difference there. Probably because 200 to the power of 100 is absolutely huge. Let's go ahead and make those a little bit more reasonable. I'm going to say integer 3 equals integer 2 to the power of 2. So let's go ahead and try that one. Again, we're trying these things out to see what our limits are. Okay, let's see how that one works out. Okay, good. So that worked. Let's see how big we can get. Let's go ahead and make this 5. All right, that's cool. Let's go ahead and make this 8. See if we can take 200 to the power of 8. All right, still pretty good. Let's make this 12. Let's see what we get. That's a big number there. Okay, now it's negative. That means that we overflowed past the maximum bits of an 8-byte integer. Now, I'm going to go back into this makefile. Let's go ahead and make this 8. Remember, when I did 8, when I said 8, it worked. Okay, we got a valid number. Let's go back into this makefile, and I'm going to delete this default integer -8 argument. Now, on Intel, it's just -i8. So on the Intel FORTRAN, it's -i8. But on GFortran, it's that f default integer. It's this thing right here, and I'll put that in the notes of the video. But let's go ahead and get rid of that, and let's see what effect that has. Remember, we got this really nice long number. Let's see what we get. And in this case, we got that nice long number again. Now, I don't remember. Did I save this? Yeah, let's see. So the 8-byte... But the 8-byte integer specification can really help you out. I don't see, let's see if we go here to 9. Let's see if we can get this to overflow. Yep, we got that to overflow. Now let's go here and let's put that setting back in there and see if we can fix this. Yep, so without this, the power of integer 2 to the 9th overflows. We get a negative result. Actually, that's not what I was expecting. I love when I have problems like this. So let's say make clean, main, or make, main. Okay, so we get a -4, 5. Let's go back and delete this. Well, the values are different. So you can see that with the 8-byte, so we've hit the limit of even an 8-byte integer. This is just, the result of that is just too big. So we get this big, long negative number. However, when we get rid of that 8, we have a much larger as a negative number. So it is different. So you can see that there are some differences. So it just so happens that 200 after to the power of 8 will overflow just about any integer data type. So you definitely want to experiment with this and see what the maximum and minimum is that you can play around with exponentiation. So again, the arguments are -f default integer 8 for GFortran or -i8 for Intel. So we'll go ahead and I'll go ahead and put those in the video notes. All right, so let's take a look at 6. And 6 is going to be simple negation. How does negation work? So I can just say integer 3 equals negative integer 1. And this is a single argument operator, which is the minus sign, negation. And the argument that it takes is integer 1. So what actually happens inside of the CPU is integer 1 is placed into a register. It is actually negated with its sign is changed. It gets a 2's complement value. If you don't know what 2's complement is, go ahead and take a look at my assembly video on 2's complement. It explains the whole thing very nicely. And then it puts that negative value in integer 3. So this is a single operand operator, the minus sign. So if I go ahead and say print, and we happen to know that integer 1, I believe, is a 100. So let's go ahead and make that. And, oh, it's a 200. Did we change? Oh, that's integer 2. I should have put integer 3 there. And there it is. It negated it very nicely. Okay, the last thing I want to talk about when it comes to built-in math is modulus. What is modulus? Modulus is the remainder of a division. So let's go ahead and create another section here. And the way that it works is that when you divide one number by another, if you take the modulus, that's going to take the remainder and it's going to place it into another variable, and that remainder is always going to be an integer. So let's go ahead and do some of that. So I'm just going to say integer 3 equals, and really, I guess this really isn't a built-in, it really isn't a default operator. It actually is a function. So I'm going to say integer 3 equals the modulus of 1112.87, 14.0. So what this is going to do is it's going to take 1112.87, divide it by 14, and it's going to take the remainder of that division. Remember your elementary school math or arithmetic. It's going to divide that by 14, and then it's going to put the remainder into integer 3. And now, the largest number that you'll get from this is going to be a 13, because it's either going to be a 0 remainder all the way up to 13. So you're going to have some kind of a value in there of 13. So let's see, we're going to say 7. All right, let's save and build. And there you can see the modulus is 6. Now, you could change this to test it more. Like you could say, I don't know, I could say 15. And the modulus would be 15 divided by 4 is 1 with a remainder, I believe, of 1. Let's see if that's the case. That's absolutely right. Then I could go ahead and change this to 16. And a modulus 2, and so forth. So you can play around with that. What is modulus used for? Modulus is used for a lot of things. One of the things it's specifically used for is converting one numeric system like decimal into binary, or into hex, or into octal. So it's very good for that type of thing. Okay, the next thing I want to talk about are numeric functions. So we're going to talk about numeric functions here. And I guess modulus is a numeric function because you had to call the function mod to do it. But there's other ones, so let's go ahead and say print.
just so I can keep track of what my output looks like. And I'm going to do the square root. So let's do the square root of a number. Now, it's always a good idea. You can do a square root of a number with an integer, but we're going to do it with a real. So I'm going to say print square root of 90, square root of real 1. Now, I haven't actually put that in there, so I'm going to say real 1 equals 90.00. I could have had 3 zeros there, it doesn't matter. And there we go. So there's the square root of 90. I could also do something like sine of 90 let's just go ahead and put a whole bunch of these in there. So we're going to say sine, we're going to say cosine. And there's the cosine. There's also a hyperbolic sine, so I could do something like this. There's also a hyperbolic cosine. And I believe it's sine h, right? Yep, sine h. And the same with cosine. And we're not going to do all of those, but let's just see how it works. Super simple there, right? Also, take a look. The hyperbolic sine of 90, the hyperbolic is infinity. That's actually kind of interesting. Let me take a look at my notes here to make sure I've got that right. Yeah, it looks like that's correct. So yeah, maybe the number's too big. Let's go ahead and put real 1 equals 10. Let's go ahead and put a 10 there. It's nice it didn't die. The Fortran didn't die. Yep. So the hyperbolic sine of 90 is definitely infinity. We could try 89. I believe that will give us a non-infinite result. But let's see. And it did. It gave us a non-infinite result. So, yeah, and we didn't really actually, the reason we're not seeing an infinity here any longer is because we set it up to be 89 on real 1. So our cosine is really not 90. It's really 89. Okay. What are some of the other functions you can use? I'm not going to create a line of code for each one of those, but there's tangent for tangent. Tan for tangent. There's hyperbolic tangent. There is log, which is a natural logarithm, or there's a log 10, which is something that a lot of us are used to just in simple arithmetic or mathematics that you took in elementary school. So this will give you tangent. This will give you hyperbolic tangent. And I'm doing this so I don't have to. This will give you natural logarithm. And this will give you base 10 log. I don't know if I've got logarithm spelled right there. Okay. So again, some of the mathematical functions within Fortran, very, very simple. Now, I'm going to go ahead and I'm going to do this, and I'm going to show you how easy it is to go from this into Intel FORTRAN. So let me create a new project in Intel FORTRAN. And here's the Linux FORTRAN template. Let's see. Well, I've got one here. So let's just go into one I already had, and I'm just going to delete everything out of that one, copy everything from my GFortran into my Intel FORTRAN, save it, and now I'm going to go to that. I'm going to go to that directory. Okay, now there is a little bit of a problem here. In Intel FORTRAN, I actually have to set up the environment before I start, and in my template, my Intel FORTRAN template, I actually have that. So if I go in here and take a look at that, I have to do this command right here. So I'm going to say, and I only have to do it once. Source, opt, Intel, one API, set vars.h. What did I do wrong? Oh, there it is. Oh, I never set up that to be executable on my Intel. This is a new Linux install. So, okay. So now it's executable. If you take a look, it's now green. If I do an LSAL, you can see that set vars now has the X attribute turned on, so it now is accessible. So I'm just going to say set vars. This is something about the Intel compiler I'm not really super excited about. And it goes ahead and sets up the entire development environment. Now I can go into the path and it will compile it and link it. And I can run it, and you can see that the results are almost identical. So the GFortran compiler is really using a lot of the standards. Now, if I want to edit, remember that large integer issue? If I want to edit that within the Intel compiler, I have to add the -i8, which I already did. I already added that in a previous session, and it will give me different values. It'll give me better values. You can see that's overflow, but it still has overflow. It's a huge overflow, or should I say a very small overflow, because it's a negative number. And that will change if I get rid of that -i8. And you'll see that it changed. And it changed almost identically to the, well, I think it might be identical to the GFortran. So GFortran and Intel. Why would I use Intel over GFortran? Well, playing around, hobbies, just trying to learn the language. GFortran is perfectly fine, but if I'm actually going to be doing some type of real coding, Intel is going to have a really nice set of optimizations within their compiler. Okay, the last thing I want to talk about is order of operation. How are things done in the computer or in Fortran when you have an equation, and how do you set up those equations? I call it operator precedence. I think most people do as well. So let's do a simple little equation here. Operator precedence. And what this means is it means in what order are things done. So I'm going to do this. I'm going to say real 1 equals 100.22. I'm going to say real 2 equals 345.99, just some, or 456.99, just the simple numbers. And I'm going to say real 3 equals real 1 plus real 2 divided by real 1. And that's a valid equation right there. But the question is, what order are these? What's going to be done first? Is the division going to be done first? Is the addition going to be done first? Which one is going to be done first? So let's go ahead and just say print let's see what happens. Okay, so we've got a 104.79869. Okay, that's fine. That may be exactly what we want. But I'm going to put parentheses around this equation because I would like the, I would like the division to go first, and that is what parentheses are used for. If I put parentheses around part of the equation, that means that that's going to be done first. So parentheses are looked for first by the compiler.
it's going to execute it's going to execute the division of real 2 by real 1. And let's put this down on the second one so we can see if there's a difference. And then it's going to do the addition. So let's go ahead and build that. Well, they're exactly the same. What is that telling me? That's telling me that by default, division is done first in this equation. So let's go ahead and copy this again. But this time, instead of putting parentheses around the division, I'm going to put parentheses around the addition. And some of you might say, well, what difference does that make? Well, let's take a look. Let's see if there is a difference. Big, big difference. So by putting parentheses around different parts of your equation, we'll specify to the compiler what you want to execute first. So what is the order of operation? Well, the first order of operation is negation. So if I put a minus or a plus sign there, it's going to take the number in real 2 and negate it first. That's the first thing it's going to do. The second thing it's going to do is it's going to do whatever is in the parentheses. And then when it gets into the parentheses, it starts over with negation. Is there any negation in these parentheses? No. Then what it's going to do is it's going to say, okay, let's do multiplication and division first from left to right. So it's going to do this division first. Well, since that's the only thing there, let's go ahead and say multiplied by 2. Which one of these is it going to do first? Well, it's going to do the division first because division is to the left of the multiplication. So it goes left to right. So division and then the multiplication. The third thing it's going to do is it's going to then do addition and subtraction. So let's do this a little, let's do it kind of like this right here and see what we get. Okay, so how are things going to happen? I'm going to go ahead and put this little equation. Let's talk about what's going to happen. So the first thing that's going to do is the compiler is going to say, are there any parentheses? No, there's absolutely no parentheses. So then the compiler says, okay, are there any negations? Are there any single argument functions? And there are. There's the minus. So it's going to negate real 2. Then it's going to say, okay, what's next? Division or multiplication division from left to right. It's going to do this division of a negative real 2 divided by real 1. Then it's going to do, the result of that is then going to be multiplied by 2. Once that is done, it is then going to add it to real 1, or it's going to take real 1 and add it to whatever the result to the right of the plus sign is, and then it's going to assign that to real 3. So again, the order of operations is negation, parentheses, multiplication, division, left to right, and then addition, subtraction, left to right. So that's the order of operation, or that's the operator precedence of doing any type of equation. Now, what do I do as a practitioner of Fortran for, I don't know, almost 50 years? In Fortran, any language for that matter, I use parentheses like crazy. I might even do something like this. I might even put parentheses around this. And the way that I think is that always go down to the deepest level of parentheses and do that first. So I know that this is going to be done first because it's the deepest level of parentheses. And then I'm going to come out of the parentheses to the next level of parentheses, which is this one. And then it's going to divide it by real 1. I've even been known to do this, and I think this is a little crazy, but I've even been known to do this. So what's going to happen in my way of doing things, it's going to go to the deepest level of parentheses, which is this parentheses minus real 2, which means it's going to negate real 2. It's then going to go up a level to this level of parentheses. So it's going to take the negative of real 2 and add it to the value of that's in real 1. Then it's going to come out and do this multiplication. If you do this, you'll never be surprised. Now, you might look at this and say, oh, that's a waste of typing and that's going to cause performance problems. First of all, it's not going to cause any performance problems. It might make the compiler work a tiny bit harder. By a tiny bit, I mean a millisecond per hour maybe, but it's not going to really cause a lot of problems. In execution, it's going to cause 0 problems because you're basically telling the compiler how you want this to work. Also, the other benefit to this is that you're telling the next person that's going to be looking at your code, this is what I intended. This is what I intended my equation to be. Let's say you want to take this equation here and you want to do the multiplication before you do the division. So you simply put parentheses around it. So that's going to assure that the multiplication of real 1 times 2 is going to occur before the real 2 divided by real 1. So that's going to give a profound difference in that equation depending upon the values of those variables. So again, it's really important to use parentheses correctly, but it also can avoid possible problems with you forgetting the order of precedence. Now you might say, well, I'm never going to forget that. Yeah, you will. There'll be at some point you'll be like, does addition happen before subtraction or division or multiplication? So it's always a good idea to do that. Now, one other order of precedence is functions. If you have a function in there, let's say if I say modulus of real 1 comma 14.22, it's going to do the function before it does anything like this division. So the function. So where would I put that? I would probably put it inside here after parentheses. So it would do a negation, then it would do parentheses, then it would do any functions within there, and then it would do multiplication, division, left and right, addition, left, or addition, subtraction, left and right. So functions might go right after parentheses, which makes total sense. You don't want to divide by mod. You want to divide by the modulus of the result of that function. So order of precedence, very, very important. Parentheses can really help you out in getting that done. All right, so that's simple mathematics, simple arithmetic in Fortran. I hope this helped you out. Order of precedence, mathematical functions. Take a look at the programmer's guide for your particular language. We looked at Intel as well as GFortran. Hope to see you in our next video.